Hello students, so we will be discussing the Hooke's law. As you all know, this is a very important law in the unit elasticity. So, the Hooke's law states that within the elastic limit, stress is proportional to strain. That is, the stress here representing is by the letter sigma and strain is represented by the letter epsilon. So, to remove the proportionality symbol, here we will use the proportionality constant E. So sigma is equal to E into epsilon, and E is equal to sigma by epsilon. If you look into the graph, you can understand that stress is proportional to strain, and that is called the Hooke's law. And the Hooke's law is valid only within the elastic limit. So now E, the proportionality constant, is called the modulus of elasticity. It depends always on the nature of the material. And we have to note that the dimensional formula of modulus of elasticity is m raised to minus 1 t raised to minus 2. Now, there are three types of modulus of elasticity, and they are classified based on the type of strain acting on them. So we know that there are three types of strains. One is linear strain, then there is volume strain, and then there is shear strain. So now the first type is called Young's modulus, then there is bulk modulus, and then we have modulus, rigidity modulus or shear modulus. Now we are going to look at what these are separately. The first is Young's modulus. So as I said, it is depending on the linear strain. So now within an elastic limit, the ratio of longitudinal stress to corresponding strain is called Young's modulus. So now what is longitudinal strain? We know that strain is change in dimension by original dimension. Here, because it is longitudinal, we use change in length by original length. So always we will be representing small letter for the change and capital letter for the original value. So it becomes L by capital L. And then we have the longitudinal stress. What is stress? It is another term for pressure, right? So it is force by area. Deforming force by the area of cross section on which the force is acting. So we will get the expression for Young's modulus equal to longitudinal stress by longitudinal strain. So we represent Young's modulus by capital Y. Then it becomes Y is equal to FL by AL. So here there is an activity for you. You have to find out which is more elastic, steel or rubber. You can use the concept of elasticity and modulus of elasticity, and of course Young's modulus, because it is linear stress and linear strain which is depending on this elasticity of steel and rubber. So we will find out which is more elastic. So next, it is bulk modulus. Bulk modulus is the ratio of pressure to the volume strain. See, when you consider bulk, it means the word bulk, it seems to feel like something which has volume. So when it's volume, instead of stress, we use the word pressure. And for strain, it is volume strain. So the reciprocal of bulk modulus is called compressibility. And here we have the expression for bulk modulus, B is equal to delta P by delta V by V, where delta P is the pressure and V is the volume. So delta V is the change in volume. Delta V by V is the expression for volume strain, as you know. So next you have the rigidity modulus. So the ratio of shear stress with respect to shear strain, that is rigidity modulus. So this particular modulus of elasticity is considered or it comes into our topic only when there is some kind of a stiffness in the material, or one side of the cube, particularly as you see in the figure, is fixed, and you apply a certain force on it so that there is a change in its angle. Only in those conditions you use the word shear modulus. Next, we have a very important topic, which is Poisson's ratio. Poisson's ratio is the ratio between lateral strain and longitudinal strain. So when it comes to lateral strain, as you see in the figure here, you can see that it is the lengthwise, and longitudinal strain, it is the widthwise. So as the lateral strain is increased, the longitudinal strain should obviously decrease, because we know that if you are considering a particular wire or a thin sheet or something, if you are considering a particular wire or a thin rod, then what happens is, as it elongates, it should reduce its width, or else we know that the other case is not possible. So here it is said that lateral strain is proportional to longitudinal strain, and the ratio between them is called So now we are going to discuss Poisson's ratio. As you know, Poisson's ratio states that it's a ratio between lateral strain and longitudinal strain. If you look into the figure, you can understand that lateral means this lengthwise and longitudinal is widthwise. If it's supposed to be a wire, this image, then as the length increases, because if we add some extra weight or something, it will elongate. But then what happens, it's longitudinal or this widthwise, it should decrease. That is what Poisson's ratio says. And because it is a ratio between the same quantities, it doesn't have a unit of dimension. So dear students, I hope you understood the concept very well. See you in the next video.